Hello everybody. This is Scientisha. Today, we are going to discuss the most revolutionary idea that gave birth to quantum physics, the concept of energy quantization introduced by Max Planck. This groundbreaking idea transformed our understanding of the physical world and laid the foundation for modern quantum theory. Before 1900, everything was going well. People were able to explain many phenomena using classical physics. But there were still some problems that we were not able to explain. In this video, we are going to learn about one such problem, that is, the blackbody radiation, and how Max Planck solved this problem. So let's begin. To understand this problem, we must first know what a blackbody is. A blackbody is an ideal object that can absorb radiation and emit radiation depending on its temperature. For example, hot iron rod. Classical physics predicted that as the frequency of the emitted radiation increases, its energy also increases accordingly. However, this would mean that at very high frequencies, the emitted energy should increase infinitely. And physically infinite energy is impossible. This led to an absurd result, that is, ultraviolet catastrophe. This was a serious crisis. Max Planck made a bold assumption that energy is not emitted continuously. Instead, it is emitted in small packets called quanta. Planck proposed E equals hf, where E equals energy of one quanta packet, h equals Planck's constant, and f equals frequency of the radiation. We must also understand what quantized energy is. It means that the energy is discrete, that is, only specific values of energy are allowed. You can think of the staircase, where you can either be on the first step or the second step. You can't go in the middle of the step. So, how does Planck's hypothesis solve the problem? As we can see, high-frequency radiation requires larger energy quanta. It becomes increasingly difficult for atoms to emit such radiation. This naturally limits the energy emitted at high frequencies, thus solving the ultraviolet catastrophe and marking the birth of quantum theory. If you found this video helpful, don't forget to like, share, and subscribe for more content on fascinating physics topics. And don't forget to hit the bell icon to stay updated with our latest videos.